Welcome back everyone. My name is Toby, and in this video we're gonna be talking about the merge sort algorithm. And to start us off, I'm just gonna define a function here and we're gonna call it merge sort. That is the name of the algorithm and that's the reason why. I understand it's not really creative, but it's just the name of the algorithm. And this function is gonna take an array and this is gonna be an array of numbers. It's gonna be a list of numbers, and it's gonna return also a list. This is what it's gonna return. It's gonna return a list. So let me just do the notation for that. It's gonna return a list, and inside this list, inside the merge sort function, the function works recursively, and in order to stop the recursive calls, we need to define a base case, and that's gonna be whenever the length of the array is equal to or less than 1. If that's the case, we're gonna return the array since we're gonna return this subarray since there's only one one number that's left. And if that's not the case, then this is where all the heavy lifting happens. We're gonna need a few variables. I'm gonna define a left variable, and this is gonna take the left the left side of the array, so we're gonna cut the array in half. This is how this algorithm works. It cuts the list into halves, and those halves into even more halves. And eventually it's gonna combine those halves while sorting them along the way. And so left is gonna be equal to array, and I'm gonna use the list splicing notation. So we're gonna start from the beginning all the way to the halfway point. And I'm also gonna do a right variable. This is the right side, right half, and it's gonna be equal to array, and we're gonna start from the halfway point all the way to the end. Now I haven't defined the halfway variable. I have not initiated it yet. I'm gonna do that right now, and I could do just the length of the array divided by 2, and I'm gonna use the floor division divided by 2. And we want to call the merge sort since right now we got the left and the right, and we need to cut those halves into even more halves. And so what we do, we call the function again on each respective half. So merge sort, and that's gonna be, we're gonna call it on the left side, and also merge sort on the right side. And here you can have a helper function, but it's not required, but typically you do have a helper function. And I am also gonna include the helper function here just because it's convenient and it makes the demonstration a little easier to explain. So what we wanna do, we're gonna call a function that's gonna take those two halves and put them together. And so I'm I'm gonna make a function called merge, and it's gonna take the left side and the right side and it's gonna merge them together, and we're gonna return it. It's gonna return the two merged arrays, and in this function it's gonna be it's gonna be combining the two arrays and sorting them in the process. So I'm just gonna make another function and I'm gonna call this merge as we established before, and it's gonna take a left and a right, and those are arrays, and it's also gonna return it's gonna return a list, which is it's an array in Python. And now in here, we're gonna wanna make a new array. So I'm gonna call this new array, and it's gonna be equal to an empty array. And this is where we're gonna combine left and right and sort them. We're gonna sort them along the way. Okay, so we want to make um, a few primitive pointers. So I'm gonna have I and j, and those are gonna be equal to 0. And these are gonna be I is gonna be for the left, and j is gonna be for the right. And I is never gonna be any larger than the length of left, and the same goes to j. The same goes to j. And so this is what we're gonna have. We're gonna have to loop. So I'm gonna have a while loop. So while I is less than the length of left, and also while we also need to make sure that the right side is never any bigger than j is never any bigger than the length of right, while j is less than the length of right. And we just want to check if the left side, if the current item in the left array is less than the current item in the right array. And if that's the case, we add the less nu- we just add the smaller number between the two arrays, and we add it in the new array. So this is what I'm gonna have while I, and if that's the case, we want to add a new array. We're gonna append we're gonna append and we need to increment I, since we've used that number. We need to go to the next number, so we need to increment I. So I plus equals 1, so we can go to the next item in left and compare it to the one in the right. And if this is not the case, if they're equal, or if the right one is smaller, the number in the right array, the right half, then else we want to add a new array, append right, and we're gonna do right j. And we also want to increment j, just like we did for I, so we can go to the next comparison. And eventually what's gonna happen is one of the lists is gonna be exhausted, one of them is gonna be exhausted, and we just wanna check. So if I equals the length of left, if I has been exhausted, then we want to we want to extend all the remaining numbers in the right side, on the right side. If that's not the case, then we want to extend to add all the numbers in the left side. And we just want to return the new array. And this array is already sorted. Okay, now let's see. Here comes the fun part. Let's see if this actually works. So I'm just gonna make some I'm gonna make some numbers here. I'm gonna make a list from 9 all the way to 0, and we want to print nums just so you can kind of see that the numbers are not sorted. And after that, we want to make nums is gonna be equal to merge sort. I'm gonna call nums again, and we're gonna print nums again so we can see exactly if it works or not. I'm just gonna save this and let me play this. Let's run the code. Oh, there's an error. Okay, I should have done that. Okay, okay, now it's gonna work. It's gonna work now. Okay, I think I know what is happening here. So, I think I know what's happening. I think one of the arrays might be empty. So, if one of the arrays might be empty, so if not left or not right, return left or right. Okay, I think I know what's happening here. Oh, okay. Yeah, I know what's happening. I just forgot to do this. I forgot to do this. Left equals and right equals that. And now it's gonna work. Now it's gonna work. I promise it's gonna work. What did I say? What did I say? I just forgot to add this. It's all good. It's all good. And there you have it, guys. That's the algorithm. So you just break the list into halves, and those halves into even more halves, and eventually you combine them. And as you combine them, you are sorting them along the way. And in the next section, you're just gonna see how the algorithm works in depth, and there's gonna be an animation that is gonna go along with that. But if you wanna show your support, then feel free to hit that like button and click subscribe. It really does help. Welcome back everybody. My name is Toby, and in this video we're gonna be talking about the merge sort algorithm. This algorithm belongs to the category of divide and conquer algorithms with a time complexity of big O notation n log of n. You could say that it's a pretty fast algorithm. And for the visual learners out there, we're gonna start with some graphics to get the big idea. So say you got numbers 9 all the way to 0, 9, 8, 7, 6 all the way to 0. And the idea with the algorithm is to cut the list into twos over and over again until you are left with only one number in the list, or until there's nothing left. It is normally done recursively, but I believe it might be possible with a normal for loop. You're gonna need some pointers slash primitive types of variables to keep track of the indices in the list. So let's go back with the numbers 9 all the way to 0. So on the first iteration, we're gonna cut the list of numbers into a left and a right half. So on the left, there's 10 numbers. We just cut it in half. There's gonna be 5 on the left, and there's gonna be 5 on the right. On the left is gonna be 9, 8, 7, 6, 5, and on the right half, it's gonna be 4, 3, 2, 1, and 0. The first iteration is done, and now we're gonna have to call the recursive function again, and let's go with the left half. So on the left half, we got 9, 8, 7, 6, and 5. If we cut that half in half, it's gonna become 9, 8, 7 on the left, and on the right half, it's gonna be 6 and 5. This is the second iteration. Um, let's go with the left half again, and we're gonna cut it in half again. And we have the numbers 9, 8, 7 on the left half. We cut it in half, and we're gonna have 9 on the left, and we're on the right side, we're gonna have 8 and 7. We're gonna go with the left again, and we cut it in half. And there's only one number left, so which means there's really not too much that we can do. So in this instance, whenever there's only one number left, since there's only 9, we're gonna return that list of numbers. This is our end goal. Once the recursive calls break apart the list of numbers into halves, and the halves also into smaller halves once they get broken down, until there's only one number left or until there's nothing left, that is when the merging happens. And we're gonna see that in action. And